Today we will learn grouping of data and histogram. Disha found the age of 40 persons living in her colony, from which she got the following numbers. Such a collection of numbers collected to get desired information is called data. Here, each number is an observation. Information from these figures, such as how many people are above 25, is not easy to find. Therefore, we organize the data in a systematic way, such as by making tables using tally marks. But it will not be easy to do this here because the number of observations here are very large. And if we show each observation in the table, then the table will be very long. In such a situation, we organize observations into different groups. Here, the smallest observation is 5 and the largest observation is 68. Therefore, the range of the data is from 5 to 68. So here, we will create groups of observations like 0 to 10, 10 to 20, 20 to 30, and so on. We call each group a class interval or class. Each class interval has a lower class limit and an upper class limit. Like 0 to 10 has lower class limit 0 and upper class limit 10. By subtracting the lower class limit from the upper class limit of class interval, we get the difference between the two. We call it class width or class size of that interval. For example, the class width or the class size of the interval 0 to 10 is 10 minus 0 is equal to 10. Similarly, the class width of the class interval 20 to 30 will be 30 minus 20 is equal to 10. Similarly, here the class width of all intervals is 10. Now we will represent the numbers in the table in the form of tally marks. Here the observation 5 is included in the class interval 0 to 10. So we will represent it in the table by making a tally mark in the row 0 to 10. Now let's talk about observation 10. We see that 10 is included in class interval 0 to 10 as well as 10 to 20. But an observation can only be included in a single class interval. To avoid this situation, we adopt a convention that a common observation will be presented in the higher class intervals. Here, we will include 10 in higher class interval 10 to 20 and create tally marks for it. So, tell me in which class interval the observation 40 will be included? Think. Absolutely right. It will be included in the class interval 40 to 50 and not in 30 to 40. So, we will create a tally mark in class interval 40 to 50 to represent 40. Similarly, we will present all the data in the table using tally mark. Now here, there are two tally marks in the class interval 0 to 10. Can you tell me, what do you understand from this? Think. Let me tell you, these two tally marks denote observations 5 and observation 8. In this way, the number 2 tells that number of observations that which are included in class interval 0 to 10, that is, there are 2 persons between the ages 0 and 10 years. We call it the frequency of class interval 0 to 10. Similarly, you can write the frequency of all these class intervals in this way. You can see that the sum of the frequencies of all class intervals is 40, which is equal to the number of observations. Thus, this table is completed. This is a frequency distribution table. Since we have classified the data presented, we now call them grouped data, and the obtained distribution is called a grouped frequency distribution. From this table, we can draw a graph as follows. In this graph, the class intervals are presented on the horizontal axis. For example, 0 to 10, 10 to 20, etc. Similarly, the number of persons are represented on the vertical axis. To show this, the scale of 1 unit is equal to 2 persons has been taken. The length of a rectangle drawn on a class interval tells us how many observations occur in that class interval. The number of observations in a class interval is called the frequency of that class interval. For example, the frequency of the class interval 20 to 30 is 6. The bars drawn to show frequency have the same width, and the two adjacent bars have no space or distance between them. This type of representation of data is called a histogram. We will understand it better with some examples in the next video. So today we have learned grouping of data and histogram. In the next video, we will see some interesting examples related to them. Today we will see some interesting examples related to grouping of data and histogram. "38 contestants participated in a dance competition. Here are their scores out of 50. Represent them in a frequency distribution table and draw a histogram for the grouped data. To create a frequency distribution table, we will create 3 columns. The first column will show the class interval of the score. The second column will show the tally marks, and the third column will show the number of contestants, which will show the frequency of the class interval. Now, we will choose the class interval. Can you tell me the class interval we can take here? Think. Let me tell you, we see that the smallest observation is 21 and the largest observation is 48. So we have to construct class intervals in such a way that we can represent these numbers effectively. Here we will make class intervals like this. You can see that the class size is same here. You can also create class intervals like this, but from the first method, we can get more clear information. Then we will take the scores one by one and represent it using the tally marks in the appropriate class interval. Here, 25 is included in these two class intervals. Keep in mind that common observation will always be included in the higher class interval. So, 25 will be represented in the class interval 25 to 30. In this way, we will create tally marks for all numbers. After this, we will count the tally marks from which we will find the frequency of the class interval. We will mark it in the third column. In this way, we have made a frequency distribution table. Let us now draw a histogram with the help of frequency distribution table. Draw two mutually perpendicular lines on the paper. The horizontal line is the x-axis and the vertical line is the y-axis. We will show the score on the x-axis. Here, we make a kink sign to state that we are not showing scores from 0 to 20. Here, the difference in the upper class limit and the lower class limit of each class interval, that is, the width or size of each class interval, is same. Therefore, we will mark the class intervals by keeping the same distance on the horizontal axis. Similarly, we will show the number of competitors on the y-axis by taking 1 unit is equal to 2 contestants. The greatest frequency in the frequency distribution table is 10. So, we can take the number of contestants on the y-axis 1 unit more than it, that is 12. Now, we will represent the frequency of each class interval in the form of length of the bars. For example, to represent the frequency of the class interval 20 to 25, we will draw a bar whose length will be 7 contestants. Similarly, we will show the frequency of all class intervals. Keep in mind that we will keep the width of the bars equal and will not keep any distance between the bars. Next example, find out by reading the histogram shown. What information does this histogram display? The histogram shows how many hours Class 8 students spend in studies. Find the number of students studying for 4 or more hours. Here, two class intervals 4 to 6 and 6 to 8 represent the number of students who study more than 4 hours. Looking at the class interval 4 to 6 and the length of the bar drawn above it, it can be understood that there are 20 students who study 4 or more than 4 hours but less than 6 hours. Similarly, the class interval 6 to 8 and its length of bar shows that there are 5 students who study 6 or more hours but less than 8 hours. In this way, the number of students studying for 4 or more hours is 25. So today we have seen some examples related to grouping of data and histogram. In the next video, we will see the misconceptions and simple mistakes related to them. Today we will see the misconception and common mistake related to grouping of data and histogram. Misconception 1. In which class interval the observation 30 can be included in the given frequency distribution table? In the frequency distribution table, children easily classify observations that are not common to two class intervals, but when they find an observation that is common to two class intervals, they cannot classify it. For example, if we want to classify 30 here, children get confused to decide if they should keep 30 in class interval 20 to 30 or in 30 to 40. In such a situation, some children think that it should be kept in lower class interval. So, they give option 1 as answer, which is a wrong answer. In case of common observation, we follow a convention that common observation will be represented in upper class interval. Here, we will put 30 in the upper class interval, 30 to 40, but not in 20 to 30. Hence, option 2 is the correct answer. Mistake 1. If children are asked to find the frequency of 2 in the given observation, then some children do not understand the meaning of frequency, so they are unable to answer this question. The number of times an observation occurs in a group of observations is called the frequency of that observation. Here, we see that observation 2 has occurred 6 times in the group of given numbers. So, we can say that the frequency of 2 is 6. So today we have seen the misconception and common mistake related to grouping of data and histogram.